And now if we go back to stock and click on stocks, it should recognize it. I know, it's not elegant, but that's the way Excel is sometimes. You have to force it to do what you want. So I'm going to delete these series because right now it's actually treating each of these 4 rows as a series. But we don't really need that information. We don't need to know how they go across. We just need to know how they go up and down. So I'm just going to change my formatting here so you could see it a little more clearly. White might be a little bit tough to see. So you feel free to pick any color you want. All right. All right, so here is our box plot, our classic box plot. You'll see that our values are sort of clustered around this end. And so one thing I might want to do is modify my y-axis so that I could sort of stretch out the values that are important to us. And the way I'll do that is go to Scale, and I'm going to put my minimum value as 50 instead of 0. And when you do that, it'll sort of stretch this part out from 50 to 80 instead of from 0 to 80. All right, and now we could see our box plot. Here's our minimum value for males, which is around the low 60s, 62. The maximum value, which is 75. Q1, which starts at 67. And Q3, which ends at 71. Here's the important thing about a box plot. So far, before in frequency distributions, we almost always had the values on the bottom. So height would be on the bottom. But now, height in inches is actually shown on the y-axis. And so, because that's an important distinction, I'm actually going to label my vertical axis to say height. Oops. Height. Okay, there we go. In inches. All right. Now we could remember, this is where height is. Notice that frequency isn't really shown here. We don't exactly know how many people have a height of 70 or 75, or if any do, right? We only know that those are the boundaries. But there is one thing we do know. We know that these are split up into quartiles. So this represents a quartile from 0 to 1. This represents a quartile as well, from the border from quartile 3 to the end, right? So about 25% of our participants have heights in this range. Another 25% have heights in this range. So using our wonderful powers of deduction, how many people are in this range? 50%. If we had a median line, we would also know where the other 2 quartiles break up. But unfortunately, in this kind of formatting with the stock plots, they don't show you median. All right. In order to see the median, because you can see it's quite an important number sometimes, let's go ahead and use the stacked columns option. So go ahead and click on Height Stacked Column. And here, I've set it up so that now it's in a format that might make more sense to you and me. Something like min, Q1, median, Q3, maximum, right? So that's an order that makes more sense to me. Or you could order it the opposite way, max, Q3, median, so on and so forth. The reason I've done that is because it's going to make it a little bit easier for us to create our box plot if it's in order. So let's go ahead and find our quartiles. Quartile. And let's find our data, put that in for males. And then a comma and 0, because we're starting with 0. And end parenthesis, enter. All right, So notice that this isn't anything new, but instead of putting in 0, here's what I'm going to do now. I'm actually going to click on this 0, because this way, the more I make things into formulas, the more I can just cut and paste and not worry about things. The nice thing about clicking on this 0 is that this is because I haven't put any dollar signs around it, it's a relative reference. And so if I cut and paste this down one, it'll cut and paste this one down one as well, right? So it'll refer to the next one down. But I don't want my data to move down, right? So let's go ahead and lock that in place and hit enter. And now once I have that, I could just drag this down, copying and pasting as we go. And look at that. We have all 5 of our values for our 5-number summary, and we didn't have to do anything. So we could see that they're in order from least to greatest. And so now let's do the same for females. So we have quartile, find our data, let's put in a comma, go back, and click on that 0 right there. And hit the end of the parentheses, enter. And then all I'm going to do is lock my data into place. Sometimes I forget and copy and paste, and it's a small disaster. All right. And then I could just copy and paste that all the way down. So far that part has been easy, right? All right, now here's where it gets a little more complicated in order to create stacked box plots. If you go to charts and go to columns, we're going to be using the stacked column. In order to use stacked column, one thing we'll have to do is find out the distance between each of these things. Because in stacked columns, what it'll do is put the next put a little box on top of another little box on top of another little box, and each of those boxes represent the distance from the previous box to the next box, right? So we're going to have to change this into distances, right? So I'm just going to put in here distance for males and distance for females. All right, so the first one is the distance from 0. So it's just exactly that. The second one is the distance from this value to this value. So the distance between. Once I have that, I can just copy and paste that all the way down, because this will give us the distance between these two. And here we have the distance between these two. All right. In order to do that for females, all I have to do is copy and paste that over, because Excel is relative. It'll say, do it for the column on the right. All right, so now we have our distances. Because of that, we could just take that and click on column, the stacked column, not the sort of side-by-side columns. Notice that right now, it's putting each row as a column. That's not what we want. We want each column to be a column. So I'm going to tell Excel, in terms of chart data, organize it this way. All right? I'll leave this over on the side. Feel free to use whatever coloring scheme you'd like. Just to keep it consistent, I'm going to go with, let's see, maybe like an orange. Maybe this one's more colorful. Okay, we'll go with the colorful one. All right, here's what we need to do now. This doesn't look like a box and whisker plot yet. In fact, there are no whiskers, right? That's where we're going to have to fudge it a little bit. One thing we're going to have to do is start by getting rid of this block. We don't want to hit delete, because that'll just delete and it will ignore that data. That's not what we want it to do. I want it to look as if these things are floating up here. And so instead, what I'm going to do is tell Excel, color these clear. So I'm just double clicking on this, and it should say fill, and I'm going to say no fill. Ta-da! It's invisible now, right? And in terms of a line, I think there might not be a line. Yeah, so thankfully there's no line. Great. So even though it's actually there, you could sort of find it. You can find it. It's there. It's just invisible because we don't really need that part. That's just the distance from 0 all the way to our min value. Here, we want this one to be our low whisker. Here's what we do. We ask Excel to also make this one invisible. Then we create, let's do that first. Let's make it invisible. Go to fill, no fill, right? And we're going to use error bars. Error bars usually start at the top of that box, whichever box you're in, right? And because we're at the top of the box, we'd like for a bar just to go through our box entirely. So we'd put a minus error bar, a negative error bar, and we'd ask for it to be 100% of our box. Notice that when I do so, you see this little line here? That's 100% of my box. So this is sort of an Excel cheat. You could hit OK. And ta-da, we have our low-end whisker, right? Great. Now, we don't need to do anything with that. We could leave that because that is our Q1 to median box. And if you hit the arrow button, the up arrow button, it'll just go to the next box up. This is the box that goes from median to Q3. And this top one as well, this is a box that goes from Q3 to max. We need to click on that, make it invisible, no fill, and we also need to give that an error bar as well. That's 100%. Now, in some of your Excel options, you might be able to get rid of these little feet so that it just looks like little bars. And so in newer versions of Excel, that's the case. That's what I usually do because I think it looks sort of ugly to have the little feet there. But you could see it's not a big deal to have the feet. And now let's change our y-axis so that we could sort of see our box plot a little better. You just hit scale. I just double clicked on it, hit scale, and I'm going to make my minimum value 50. Hit OK. Right? And now I don't want it to say distance males. Instead, I'd like it to just say males. So what I'm going to do is just change this into males and females. And then Excel will do this automatically for me. Finally, it'll label it automatically for me. Finally, what I'm going to do is add a little label to my vertical axis so that I remember that height in inches is being shown here. And so here we could see now that the quartiles here sort of split up quite nicely, but the quartiles here sort of seem to be that there are more people, these are all equal, they're 25% of our people, but that there's a greater range on the low end than on the higher end. So the range, the spread is bigger between Q1 and median than the median and Q3, right? So our second quartile is slightly fatter than our third quartile, but our first and last quartiles, first and fourth, those are even bigger than these two. All right, so although that's a bit of a fudge, you could see we could use stacked columns in order to create box plots as well. All right. So that's what I mean by it's slightly idiosyncratic. It's not the best way, but it can be done. Now let's talk about when box plots are actually useful. The pros of box plots is that you could plot a single quantitative variable and you could compare two or more distributions really easily. In fact, box plots are really useful for comparing lots of distributions very quickly because it's a good visualization, it's very compact, you could put it all on one graph, and it's easy to compare the boxes. When distributions have many, many values, too many to show individually, you wouldn't want to use a stem plot or a dot plot. You'd want to use something like a box plot. Also, it's nice when you don't need to see anything more than a 5-number summary. But one of the cons is that you can't see frequency accurately. For instance, you can't see how many people have the height of 72, right? But you can see a frequency within a range. You know that 50% of the people lie in between, Q1 and Q3, and you could see that really easily on a box plot. Now, how do we determine whether we have outliers in our data set? Well, outliers are simply extreme values, but that's a really subjective way of defining it. How do we know how extreme? Who defines extreme, right? Well, we have a rule of thumb in statistics. Typically, we determine outliers by saying that an outlier is 1.5 times the interquartile range from the nearest quartile, right? So what we really mean is the upper limit is the nearest quartile is Q3, and you add 1.5 times the interquartile range, whatever that is, right? So that's sort of the upper limit boundary. The lower limit boundary would be from the Q1 boundary, and because we're going lower, we're subtracting 1.5 times the interquartile range. Sometimes with skewed distributions, where the 5-number summary is really useful, you might not need one of these because one side might not have outliers, only the other side does. So if it's right skewed, we'd only have an upper limit boundary. If it's left skewed, we might only have a lower limit boundary. So we're going to also learn about how to signal outliers in an Excel data file by using conditional formatting.